So I'm not used to doing this introduction in English because usually this podcast is in Japanese. So bear with me if it's like a lot of ums and ers. But this is the UIT Inside podcast. UIT is the front-end organization at LY Corporation, which is a Japanese company, and our major products are the Line Messenger, which is the leading messenger in Japan, and then Yahoo Japan, which is the search engine Yahoo, but the Japanese version of that. And today I'm really, really excited because we have the most amazing guest ever on. We have Dan Abramov on the podcast. Dan, can you introduce yourself?
Hi, thank you. My name is Dan. I guess I used to work on React, so that's how you might have seen my avatar on GitHub sometimes. And then I used to work at Blue Sky, and now I'm working part-time on the Next.js team at Vercel.
And you work for Vercel Japan, is that right?
That's the plan. So currently I'm still in UK, but I submitted the visa documents, so we'll see how that comes through. But the plan is to relocate to Japan possibly at the end of the year.
That would be so cool. And you're always welcome at our office. By the way, the visa documents can take quite some time. I applied for permanent residency in Japan, and I applied 16 months ago. So.
Okay.
But I hope you can get fast track.
Yeah. So.
Yeah, and obviously I had you introduce yourself, but you don't really need an introduction. When I told my colleagues that you were gonna come on the show, they were all so excited. So you're not just famous in the English-speaking world, but every Japanese developer also knows you, every front-end developer.
Oh, I thought people already because I disappeared a little bit from the scene. I think there's a new generation who I haven't really talked too much.
Yeah, I guess there's a new generation as well, but you're still the legend, I guess. So we had a meeting last week on Thursday, and I was yeah, Dan is coming on, and they all spammed the chat with emojis because they were so excited. And I've never had that happen with a guest coming on before.
How cool. Well, appreciate it.
But today we're not talking about React. We're actually here to talk about something completely different, which is the ATProto protocol. So ATProto, what does ATProto even stand for?
ATProto, it's AT protocol, and then AT supposedly stands for authenticated transfer. So I think that's kind of the formal name. I think really the reason is because it looks like, at symbol and that you use in usernames, and it's a protocol that has to do with identity. So it's kind of like when you say my Instagram handle is at whatever, except it's an internet protocol instead of something specific to a company.
Okay, so you and I are both on Blue Sky. So I think we have quite a bit of contact with the AT protocol, but the majority of Japanese developers is still stuck on Twitter or X, and they might have never heard of ATProto. Can you just give us the 100 feet bird's eye view of the protocol? What is that?
Yeah, it's very tricky to answer because a good protocol stays invisible, in the sense that it's a way to build social apps. Not necessarily social, but I guess that's an easier maybe area to focus on. It's a new way to build social apps where that was originally developed by Blue Sky, the company that you might know as a Twitter clone product. But really, originally they were supposed to do that with Twitter itself. It's just that Twitter broke the contract with them. But the thing that they originally wanted to build is a generic kind of universal internet protocol that, I've tried to describe it in different ways. I don't know which one resonates. It's different audiences understand it differently. One way I would describe it to web developers is that it tries to extract a identity layer for the web. So it's kind of each app has its own, login, and then for social apps, you can create different kinds of things in the app, but they kind of stay within that app, right? If I write an answer on Stack Overflow, it's kind of stuck inside Stack Overflow. If I write a comment on GitHub, it's kind of stuck inside GitHub, in the sense that these companies kind of own what I made using their products. And then if these companies start changing in ways that you don't like, really maybe you can abandon them, but then you've invested so much effort and so much content into these like closed spaces that they control. And the idea of ATProto, or shorter ATProto, is to kind of lift that out so that everything works more like files, I would say. So, when I like post on Blue Sky, I'm not actually putting stuff into the Blue Sky app, although it looks like this, right? Like if you just use it, it kind of looks like it kind of looks like Twitter. Or if you use Tangled, which is ATProto, like GitHub alternative, it kind of looks like GitHub. But what happens behind the scenes is actually, it's almost like I have a folder somewhere in the cloud that has data from all of these apps as JSON. So it's kind of like everything is stored as JSON in this new layer of the web that is kind of app agnostic. It's not it's not controlled by like one company necessarily, right? You can like host this folder with different providers. You can host it yourself. It's really cheap, but it's like app agnostic, and as a result, anyone can start a competitor to one of these services or one of these apps with all existing data already there and kind of already interoperable with existing apps. So like if somebody wants to start a competitor to Blue Sky, and this actually happened, like there's a like Black Sky, which is like it has different moderation policies and so on, but it's completely interoperable with the Blue Sky app, even though it doesn't use the Blue Sky API. So that is the big thing. It's like every app on ATProto, it's kind of like a shared API where you don't need to provide an API as the app author, because every app, like all apps, kind of just write to these files, so to speak, like this JSON. So it's got like a common way it's like a way for apps to, in a sense, talk to each other, or like show content from each other and augment each other without actually talking to each other. So without exposing an API, because the protocol itself is kind of the API. So that's like there's a few other ways like I like to explain it, but I think that's kind of the big idea, is just like freeing the stuff that we create from lifting it out of apps and making it live on an independent layer that we actually control as users, so that everything we create kind of is more like files, I think, under the hood, but with the same normal user experience, like for like the app user.
And you actually have a great blog post on this. You have like a social file system as the blog post. It's on your blog Overreacted, and it sort of like talks about what you just did the perfect summary. Actually, we can just end the podcast here, but I think we want to dive a bit deeper. And since this podcast is mostly for web developers, I prepared a little ambush for you. So ATProto is a protocol, and web developers usually are familiar with the HTTP protocol.
Yeah.
So I sort of wanted to go up the stack layer by layer and like see where they differ, what ATProto offers on top of HTTP, how they even build on each other. Mm-hmm. And this might be like a check of your HTTP knowledge, but we'll just keep it real simple and easy. And so the layer 0 of HTTP is, what is HTTP even for? It would be like communication standard between clients and servers. Mm-hmm. And you already hinted at this, but like, what is the layer 0? What is it for behind the ATProto protocol?
Yeah, ATProto kind of builds on top of multiple things, and it's it builds on top of HTTP, DNS, JSON, WebSockets, CBOR, and I think maybe these are the ones that I know. I'm sure there are like other things, but it's like WebSocket or HTTP as the transport, and then CBOR as encoding, I think, for JSON, and then DNS for a bunch of things.
So it doesn't really like try to reinvent anything on how the internet works. It sort of builds on top of the existing transport layer of the internet.
Yeah, and it's kind of like what is, well, I guess it has a few of its own inventions. Like I would say there's something called lexicon, which is a JSON type definitions. So they did not go with RDF or JSON LD or whatever. I think that's what JSON schema. They made their own because none of these things quite fit what they wanted. So there are some custom pieces, but it tries, where appropriate, it tries to reuse existing primitives. And I think for example, domains as handles is one example where, it's instead of inventing its own handle system, it's it has to be centralized in some sense, right? Because somebody has to determine top level mappings, who owns this username. And they decided, well, this already exists on the internet. It's called domains. So we're just going to use this existing system for this. And I think there's a lot of that in the design. And then there's also cryptography. Yeah. So in addition to all of this stuff, there's also, not in the sense of crypto, blockchain or whatever, even though there is one element that is maybe reminiscent of that, but we can get to that if we want to. But overall, it's much more like the web, but there are cryptographic signatures and public key, private key cryptography.
The math part of cryptography.
Yeah.
So whereas HTTP has so HTTP and ATProto both have URIs. And for HTTP, everyone in the web world knows it's URLs. You have a domain that maps to a server, and the DNS helps resolve the path to the server. But in the ATProto world, what is the common URI? What is in there?
Yeah. So in ATProto, all URIs, first it's worth, just we're talking about at URIs, right? So it's @ and then what all goes after it. So I think the first question is just what does it point to, right? HTTP URI, it can point at a song or an image or an HTML page or something like this, and then maybe this HH has more links. In ATProto, all at URIs point at records, and a record is a piece of JSON with a typed schema. But a record, essentially, ATProto is every at URI points at some JSON, so something you, for example, a blue sky post is a piece of JSON. A tangled, this GitHub alternative, tangled star, you can star a repository there, a star is also a piece of JSON. A blue sky follow, if you follow somebody, then that's a piece of JSON that says you follow this person, right? So it's the stuff that you kind of create, these documents or records through the apps. And then these records can link to each other. That is kind of the big idea, is that, for example, if I comment on your post, each of us has this folder or a repo where all of our stuff lives. But the important part is you have yours and I have mine. So that is kind of the big idea also, that we each of us owns just our own data. And sure, maybe we use some hosting for that, behind the scenes, right? When I sign up for Blue Sky, I don't think about where it lives, but I actually moved the hosting. So you can move it over time. And so all my stuff is in my repo and all your stuff is in your repo, right? And for example, if if 10,000, I'm going to give you actually a test to see if you understand it. So if 10,000 people follow you, where do these follow records live? Are they in your repo or are they somewhere else?
I would say they are distributed across 10,000 users, right? Because everyone holds their own follow state.
Exactly. So if you have 1 million followers, they're not actually yours. They're one follow record per each, person who follows you. But then if you follow 1 million people, actually that's 1 million records in your repo, because it was your choice to follow them. So now that we kind of understand that, your stuff lives in your repo, my stuff lives in mine, if I comment on your posts, that's a comment record in my repo that has a link to posts in your repo. And that's where at URIs come up, is I need a way to link to something that exists in your repo, to some piece of JSON. And so we kind of have this web of JSON where instead of pages with links, we have JSON with links. But that is where the need for actually for a separate protocol comes up, and why we have it. Because if we just use HTTP, like imagine that, there is some server hosting you, like your hosting company.com / use like your post, and I just link to that from my repo. That means that you can never change the hosting company without breaking the link. So that is, right, like it's kind of like we have the domain system, which lets whoever hosts the content change, where it's hosted, like change IP address, but it doesn't let you, like there's no way for you to decide to like move off of that thing without breaking the links, because it's hosted by some hosting company.com. So that link will break if you move away. And from like a product design perspective, like that is the big reason why everything went wrong, which is if we put stuff into these apps or into these boxes, and then it stays there because we can't, they have power over us. And so coming back to your question, like what is in the AT protocol, you have like AT, like what's that beginning. And so in that protocol link, it also starts with domain authority. So it kind of looks, you may see like AT on colon / Dan Abramov, Dan is my domain, / and then like it will be like Blue Sky post or something / and then ID of that post. But the important part is that the first thing is actually not where it's not where it's hosted. So it's not the physical server. It's not the domain for the physical server. It's my username in a sense. And so there is an extra resolution step where we find out, okay, for this username, where is the current server where this is hosted? And then it goes to HTTP to get it. So it's kind of like one indirection that it kind of puts like usernames before the physical storage. And that lets me, over time, I can change where my actual hosting is, and none of the links will break. So that is kind of the big motivation for why it's done this way.
So if I rephrase this in my words, the issue with HTTP is that it uses URLs, and URLs are pointing at locations. And the issue is that those locations are a matter that can change. So they're like sort of ephemeral. But ATProto says we somehow need this to never change, to have some resource identifier that will always point at your repo.
Yeah. Okay. Or you could say that it kind of puts people first, like literally, because then you're the authority part of the URL is the physical host or the location, and then in AT URI, which is there's like a tangent about like it being URI or not, but essentially the first part, the authority part, is the user themselves. So it's not like Blue Sky / me, / Dan something. It's like Dan Blue Sky / something. It's like, it inverts the relationship so that the user comes first. And there's a nuance that I just wanted to flag, that like the first part, like we talk about like the username, that's kind of the friendly way to write an AT URI, but it's actually also unstable because you can change your username over time. So there's a kind of the full form of AT URI. It starts with something called a DID, which is just a permanent identifier that never changes. So this is the thing that's like forever immutable as long as you're in control of your identity.
Okay, I want to come back to the DID part because I think it's really important. I didn't know it was pronounced DID, no pun intended. But so to get this back to the HTTP discussion, in HTTP you would have a domain, which there's a matter where you could perhaps lose access to your domain. And the domain sort of allows you to obfuscate where your data actually lives, but you could lose the domain, and that's the issue. And to solve that, the AT protocol adds a different layer that says, no, the domain or your server is not what we're looking for. The identity is what we're looking for. And if we have your identity, we can resolve that to where you host.
Yes, I wouldn't say it's because you can lose, although certainly you can lose the domain, but I think it's more about, if we're talking about, something like a tweet, right? Like it's not going to live on your domain anyway. Like it lives on, on Twitter. So if we try to design, this thing with HTTP, then the HTTP URI would be like twitter.com or like Twitter datastorage.com or whatever, right? But then the problem is you can't walk away from Twitter now and use a different app without, like, you can't get rid of Twitter without breaking all these links. So it's more about that you're, like, when we hosted our content ourselves, like when each of us had a site, right, we were directly connected to how the internet works. Because if we don't like the hosting, we just change our hosting, but our users don't need to know. They just still go to our site, it still resolves. But when we moved into social spaces like Facebook or Twitter or Stack Overflow, we're now one step disconnected from how the internet actually works, because we can't change our hosting. Like, you can't change your hosting when you're using Twitter, right? Like, Twitter couples the app and the hosting. And so the idea here is actually, let's still make your content live in a different world where you can change the hosting, and it's app agnostic. And the app is just one of the consumers of, of this, like, a layer of the internet. Like, in that sense, I kind of like to think about it as similar to RSS and Google Reader, right? Like, you control your RSS, you can move, like where you host it and so on, but then you can consume all of the RSS you're interested in from apps such as Google Reader, but they actually have no sway on the, on the underlying system. Like, if Google Reader disappears, somebody else can make an RSS client that reads from all of them. So it's about avoiding lock-in, really. It's not so much about, like, it's about removing the power from the apps to kind of keep you locked down.
That's a really nice way of putting it. And now that we know the promise of the AT protocol, I kind of want to dive into how it works. So you said there's like this DID that can be resolved to your identity. For HTTP, the domain would be resolved to your location via the DNS server. You do a DNS lookup and you get the IP address. How is the DID or DID resolved to you?
Yeah, so let's first start with what a DID is. So this is kind of it's a W3C standard. So they try to reuse like this part, but it's kind of a meta standard in the sense that it doesn't actually specify how to resolve a DID. It's more like a DID is a format where first it says like DID : and then there's something called DID method. So this can be, like I think it's maybe 3 letters, or maybe it can be more, but it's kind of like the method actually specifies how to find a certain thing, like a piece of JSON that's your identity, but it's method specific. And then from that point, like the rest is identifier for this method. So it's almost like a DID is just kind of a universal, let's make many ID systems under one umbrella. And then ATProto picks 2 ID systems supported by DID because they satisfy certain properties, right? Like on property, you want it to be, kind of fast to resolve, right? So something like, I don't know, download all the blockchain and whatever, like that's already like a non-starter. Like it has to be something that's like easily resolvable. It has to, like, I don't remember the exact properties, but they basically picked 2 things, and one is the one that they invented. So there are 2 DID methods supported by ATProto. One is called DID_PLC, which initially stood for placeholder because they thought they're going to replace it. And then they thought, actually, it's quite good. We're going to keep it. So one is PLC. Now it's supposedly public ledger of credentials.
Okay, that's crypto like ledger. I hear.
Well, I think that is an influence from that world. I think, yes, but it is not. It's actually not distributed. This is the part that's like centralized. It's kind of like an npm registry. And the other DID method is DIDweb, which uses just a normal domain lookup. So these are kind of like 2 ways this can work. In both cases, the goal is to resolve to a piece of JSON that is called your DID document, which I kind of like to think as a passport. It's a piece of JSON that says 3 things. One is where your stuff currently lives, so your hosting, your like HTTP hosting. Another is what is your handle, so that's your like domain username. It can be completely different from like where it's hosted. These are completely unrelated. And the third thing is what is your public key. So if somebody wants to verify some record or whatever, what is the public key that they verify against? And so, but yeah, these are like two methods, and the difference between them is one is more centralized. They're, like legally, they're kind of spinning it off into like a Swiss organization that's going to be independent. And like the idea, like it's kind of like the goal is for it to kind of evolve similar to how top like root DNS has evolved with like ICANN and, like some kind of thing like being managed like neutrally. But it's like being centralized is kind of the point, because that is the authoritative place to say who, what's under this identity. But they came up with a bunch of things that kind of make it less of a problem that it's centralized. So for example, it's like it's entirely open source. There is no private state in it. So like it's actually like fully kind of replayable just based on public data. You can like audit it. Like there's an audit log. You can change in every transaction and so on. So it's like highly auditable, but it is an essential thing. And so that's kind of the usual way. Like if you sign up on Blue Sky, you're going to get a PLC, and then PLC is the thing that holds your like JIT passport or like JIT document. But if you like hate the idea of like anything centralized, there's JIT web, where your username after that is literally like the identifier part is literally a domain instead of like a hash, like in JIT PLC. In JIT PLC, you get a hash. Indeed, we get a domain, but then if you lose the domain, your identity actually, you can't control it anymore, like it dies. So that's kind of the choice for like hardcore decentralizers.
So PLC directory is the centralized place to look up bits that use the method of PLC. And
yes,
public ledger sort of implies that there is like a way I can look up the ledger and see that like, first I can see what happened on the ledger. And public means that probably everyone can look it up. Can I just go and like do a HTTP request somewhere and get like info about my
there's something called so plc.directory is I think the the website. It has an example where JIT resolution can be as simple as curl-s http plc directory /JIT, and then that gives you your JSON. So there's kind of an API there. There's also API for like curling like the past versions, so you can see like for every JIT document, what does it say now, what has it said in the past. You can verify that each change is signed by a key that is like the public key of the previous version of the JIT document. So you can kind of verify like that independently verify that JIT document could not have been fudged because it's signed by the user's private key, which the PLC registry doesn't have. And then the first version of the JIT document, when hashed, that hash is your identifier on PLC. So you can verify that the first version is also correct because it's also like it has the signature. So it's like it's a hash of the signed version of the first document. So you can recursively verify for every user the entire chain of changes to their identity, including changes to hosting, to the key pair, and to the username.
So it's a cryptographically verifiable chain of events of what happened to your passport, so to say.
Yes.
With no loose ends, because the first entry is the JIT yourself, the identifier yourself. Okay, very cool.
Yeah.
And you said there's like 3 parts living in there. There's your alias. There's the part where your data lives. And then what was the last part?
The public key.
The public key. Okay, so people can verify that it's actually what it claims to be. So so where does the data actually live? Like what would be in my JIT document?
So for example, it depends on how you made your ATProto. Like we call it the atmosphere, like this layer above the web. This is like atmosphere, right? Like ATProto. So it's kind of like, it's having like an atmosphere account. It's kind of like having Google account, except it's the web, right? Like in a sense, it's like the web account. That is, I think that is like part of the idea is like that we just all have these web accounts instead of, like many kind of accounts that are tied to a specific provider like Google. And if you follow the JIT document, it will say, for example, if I sign up on ATProto through Blue Sky app, it will have to create hosting for me, right? Because I don't have ATProto hosting that already exists. So the Blue Sky is kind of 2 different things actually. There's Blue Sky hosting, like under the hood, right? And there's Blue Sky app, and they're completely independent. So I changed my like hosting to a different provider. Actually, you can also self-host, so you can run the server yourself. It's it's really cheap. But yeah, this like hosting part, if you sign up for Blue Sky, it's gonna say something like, some server.bluesky.network or whatever. And so this is the server that will host your JSON that contains your private key, and that is able to serve, your if like apps want to know like what you have posted, it can serve your posts, or all the other like information from other Atmosphere apps. And it also provides a WebSocket connection for notifying about changes, and that is why this whole thing works real time, right? So it's not kind of just like pull. It's more like apps can subscribe to your hosting, and then they're notified when something comes out, so they can immediately ingest it and put it into their databases.
So for traditional web, this would be, for example, the Twitter server. I want to post something to Twitter, and it goes to the Twitter server. But in ATProto, this is the PDS part, right? Personal data server.
Yes.
And my data only lives on one server. So it's like a one-to-one mapping of my DID document and a PDS.
Yeah. Your data always points to one. I mean, one server can serve many users' data, right? So like it scales, but your own stuff only lives in one place. Yes, and this is like the source of truth, right? Like then the apps, of course, will consume it, and then they have their local caches or databases and so on. But it's kind of like the source of truth is your PDS. Yes.
So I think I'm on the same PDS as you. I'm German, and I moved to eurosky.social.
Mm-hmm. Yeah.
I think that's the PDS. And I did like a migration and everything. And I think that's the interesting part you talked about earlier. Like since your identity stays in one place, you can like switch where your data lives, and like everything follows it around. So I had like a Blue Sky account, and that I think initially signing up there left me with the default Blue Sky PDS. And then I did a bunch of posts, a bunch of likes. I followed, of course, Dan Abramov on Blue Sky. And then at some point, I wanted to move that to Europe. And what happened behind the scenes there when I did the move, or like the migration?
Yeah, so the first thing that happened is like all of your JSON has your repository. It's kind of like pushing, if you're familiar with Git, it's kind of like pushing Git to a different remote. Like I think that's what it is. Like your repository has been pushed to like another place, and then the last thing was like once it was like you also had to, I think like migrating media is currently kind of wonky. Like you have to use a separate tool to get all the image files migrated, which was a bit weird. But like I think they're planning to like improve on this so that the actual migration goes server to server. Because I think it was like server to client to server, which is why it's like so strange. But like ideally it would be like much faster and a smoother process. But then once that repository appears on the other server, the last thing that happens is you submit a change to the PLC registry, right? So there's a request that says update my passport or my DID document to say now this is my hosting. Now this is where, this is the HTTP endpoint where my content actually lives. And so that is the last part. And then that change is going to be broadcasted from PLC. So apps, I don't know. I guess PLC does it does have an audit log, but I think the dominant model is just that apps cache identities over like 5 minutes or like hour or whatever. So like later, like next time they try to resolve your DID, they'll be like, oh, like, okay, the content is hosted somewhere else. But for most apps, they don't even need to do anything because they've already cached all the data by its AT URI, and the AT URIs did not change. So it's like, well, who cares that, like if they need to refetch it for some reason, they can go to your new server. But really, like for apps, it doesn't even matter because it's like most apps, well, I guess many apps just cache stuff.
So basically what I did, I had like a repo with all my data, and I had that on GitHub. And then I did a Git clone pushed it to GitLab instead and deleted the old repo on GitHub, and then updated my passport to say, hey, my data now lives on a different GitHub.
Yeah.
Okay, that makes sense.
Yeah.
And in this repo, like what you said, there's like a bunch of JSON living in the repo, but what exactly, what kinds of JSON are there?
Yeah, there's actually a great tool to inspect it. So there's something called PJS. So if you literally type PJS as in personal data server .ls, ls as in Unix ls utility, for listing files, it's going to give you this like thing where you can input any Proto handle. So you can, input your domain if you have a Proto account associated with it. And it's just going to show you the whole repository. So it's going to show you there's like collections, which are kind of like folders. Yeah, like if you search for Dan or like for yourself. So now it resolves the did, it resolves the, you see, like now it says Eurosky social, so it resolves where your host actually lives. And then these collections are kind of like folders. So they're grouped by type. So these are all like kind of different types of JSON, and they're app specific, right? So like Blue Sky app has their types, and then like npmX has its own types and so on. So like every app developer, you can come up with your own. Like nobody is kind of policing them, so anyone can. But they're sorted by reverse domain, which kind of gives you them unique prefixes, like naturally. So like if you work on some app, you just put your app's domain there. It's kind of like your namespace, kind of like scoped packages on npm almost. And then if you go into any folder, you're gonna see a list of JSON files or like records in that folder that all have the same type, and it's just normal JSON. So it's just like a like would be a JSON object that says which post was liked, for example. And these are going to be links. So if you click into like a like and click into any specific piece of JSON, there's actually going to be like specific, like this is a like for a certain post. And if you follow the link to the post, you might end up on like a different person's repository with the actual post.
Okay, so for the people listening to this podcast, I just navigated to pds.ls. And then I put my alias, so my email, my domain, theosteiner.de on there. And then sort of did the did lookup. Is that how you call it? The PLC lookup.
Yeah.
And it found my PDS, which in this case is eurosky.social. And below that, we had like a bunch of a bunch of collections. And the collections are all of a certain type, I'd say. And the type is like a reverse domain identifier. So for Blue Sky likes, it is app like. And if I click on that, I get all the likes I ever did on Blue Sky. And if I click even deeper into that, I get the actual JSON. And here it says, so it has a timestamp, a created app. And then it has like a subject, which I assume is the part.
Yeah, there's the post you liked.
Why does it have a URI and a CID? So URI is the thing we talked about earlier. This will resolve to somebody else's did document, and then from there we can get the PDS, and from there we can get the collection, and from there we can get the entry, the post of the collection. But what is the CID?
Yeah, CID, there are like two types of links in ATProto. One is kind of like a weak link, or like just, I think it's called a ref, which is just a normal AT URI, and then another one is called a strong link, which is URI and CID. And CID is just a hash of the linked record. So the idea is like, if for some links you maybe want to, like you want the apps to be able to tell, is the thing that it relates to the same as it was when, for example, like for the like if the post was edited, does that still count? And I think Blue Sky app actually doesn't. I don't know. I don't think it reflects edits. Like I'm not sure. Like I think maybe it doesn't. So this is like application's choice to kind of disregard edits, or it's like a product decision. But if they ever allowed edits, this would allow to say, was your like on the on the version that's there now, or is it like has it changed since the like?
Okay, so if for example I liked a post that said tabs are better than spaces. And then at some point, the editor, the poster, the author of the post went back and said, spaces are better than tabs. I can point at this record and say, no, because the hash changed. Back when I liked it, it was a different post. Okay.
Yeah.
And what is the dollar type field here in the JSON?
Yeah, so this is the name of the collection it's in. It's kind of a convention that it's just always going to be there. So it lets you tell just from the record what kind of record it is without looking, without even knowing the URI. So it's just the folder name, the same thing.
So a like would have a very different data structure to, let's say, a post. How does Blue Sky know how to parse those records?
Yeah, so this is an interesting question. It's kind of like you can optionally publish, there's something called lexicons, which are kind of like type definitions. Like I really think of them as a lexicon. There's for each of these types, like a Blue Sky like, Blue Sky post, Tangled repo, npmx follow, whatever. Like each of these things has a schema associated with it, written as JSON. And actually, the funny thing is you don't have to publish them, so it's only it's useful for apps because apps there's like tooling that generates like actual parsing code and like validation or like Zod validation, or so that you can safely read it into like a typed form in any language. Like there's for JavaScript or Swift and Go and so on. Like there's like a code gen libraries that do this from lexicons. So that's why. But the thing is, you can also publish lexicons. And the funny thing is, the way you publish them is they're also records. So you can publish a record with the type definition. And actually in PDSLS, if the record is in, so if the type is published, you can actually click on it as a link and it will show the record. So if you like in that, on the screen that you were showing where you had the like record and it says type @BSky feed.like, if you press on it, there's like a lexicon resolution mechanism which says how to find the record that has the schema for this type. And PDSLS actually displays it like nicely almost like as a documentation like format. So that's
really cool. So this is like how they allow storing arbitrary data, because there's a way to define how data is structured, and every app gets to define this themselves.
Yes. Although it's even more interesting because like I think that is kind of the starting point. As a developer, you just choose your own formats, but you can also just choose to reuse existing ones, right? Like you can decide that you're making maybe a plugin for Blue Sky, and then you use like the Blue Sky follows as a format for your thing, or you can make maybe you're making some kind of a annotation like community notes feature or something like this. Like maybe you're making like a product. Well, in this case, like it would make sense for Blue Sky to do it, but maybe you're making some kind of like annotation thing. And then you could allow the target of your annotation be like Blue Sky posts or, Tangled repos or like anything, you can link to anything. So in that sense, like it's like you can use other apps formats, you can kind of link to them, or you can literally like use that as your own format. And the same as like, with file formats, right? Like we have many apps that use the same format. And with that's actually like there's been like precedent in there is like 3 blogging platforms on ATProto. One is called Leaflet, another Offprint, and another is called Pocket. And at some point they actually worked together on a single lexicon because they wanted to be like more interoperable so that subscriptions from like one show up in the other and so on. And so they actually agreed on the format for like a publication or like a follow, and this is called standard site. It's become like a kind of a bigger thing than this. Like it's kind of like RSS on ATProto in a sense. But the funny thing is like now you can also like adopt standard site for your own blog that's like not hosted on any of these platforms, and like create records for your describing like your posts and your publication, your like brand colors in the publication. And the funny thing is like now links to any standard site posts on Blue Sky app will be shown with like a special treatment with like a box that has the color, the branding color of your site. So this example where like 3 different blogging platforms decided to share a lexicon, and then the Blue Sky app decided to read that lexicon and like to use the information from it. So in that sense, like it's a much more dynamic kind of ecosystem where like some things get kind of standardized in a sense, but completely community driven.
This is kind of wild. This is like, I built my own app, and to kickstart it, I let my users post from my app to Instagram. And I let them post pictures to Instagram, and I can also display every picture they posted to Instagram. This is the moment where it kind of clicks.
Yeah. Well, the other thing is like you can index things of different types, right? So, of course, indexing, for example, like all Blue Sky posts is like crazy in terms of volume, so that's expensive.
Mm-hmm.
But you could maybe index like something that relates to the user, and then you can do this kind of like mashups where there's another funny example. There's this lexicon, Last.fm.
Yeah.
The music tracking thing. Yeah. So there's a lexicon called Teal FM Play, which is like Teal FM was like supposed to be something where you're gonna track your music usage, but then I don't think they still like it's kind of been in development for a long time, but they're doing it on like weekends, so they still haven't launched the actual website or like the app. But it doesn't matter because the lexicon exists. So they already made tooling to actually submit what you're listening to, even though there is no app. It's just you're just writing records of this lexicon. And so people have already made there's like third-party apps that display your listening stats on Teal FM, even though Teal FM does not exist. So it's kind of funny. And like you can show like aggregations across like what are top listened artists on Teal FM, but again there's no Teal. So it's and the thing is like you can also like the way I kind of think about it is like if you had the world's JSON, like why not run joins over products, right? Like you can do things like top tracks that your follows on Blue Sky have been listening to. Right, you can be like, what are the repositories that trending repositories from your friends or whatever. Like you can kind of combine data from different apps and cross-join it, which I think is like that feels like the web to me. Like that's kind of like taking the web idea, kind of like a web database. I don't know, like it's like breaking the boundaries or like blurring the boundaries between apps and making it more like there's the web of data, and then the apps are just like lenses through which we, kind of look at that data. Mm-hmm. And these lenses can be, anyone can create a new one.
And like posting records across products sounds kind of crazy at first, but since it's the AT protocol, so it's like authenticated transfer, which means you have authenticated everything that is posted to your repo, and that's why it's safe to post across apps, right?
Yeah, so the way this works is like, apps can be sure that the content is really because they can always like resolve it through like the AT protocol. They go to your hosting, and then your hosting returns them the thing, and it is signed with the key that they can verify that that's the key in your in your registry or in the document. And then the other clever thing that they do is there's, of course, you need to somehow scale up the network, because you can imagine there's like million, for each user, there's a hosting. Of course, like a lot of users are going to be on the same hosting. So the hosting can be like from like hosting like 100,000 users to like maybe a solo user hosting, like both of these are kind of valid. But that's where the data lives. But then you somehow need it to flow into all the apps, right? And like it's inconvenient for apps to, you don't want them to smash like all the hosting all the time to kind of figure out what happened. So like apps maintain caches and subscribe through WebSocket. But then there's a question of like, again, how do you scale it further? Like you kind of want some shared infrastructure, right? Like you want some shared caches, you want some shared like retransmission from ideally like you want to, like there should be like a way to just subscribe to WebSocket to one event bus that has, that kind of multiply, like that has like information from about everything that happens on the network, or this like subset that's like relevant to your app, maybe like your app's collection types and so on. And so what the clever thing they did is that you can build, and then there are retransmitters like this, like they're called relays. Like Blue Sky runs one. There are like a bunch of community run relays that let you just subscribe over WebSocket to like everything that happens on the network. And then the stream that is passed is like a stream of commits, right? It's like a stream of events about commits, identity changes, and so on. And the stream is retransmitted with proofs. So the stream contains the like signed, like each commit is, it's got signed commits in Git, I guess. So each commit is signed. So you actually don't need to trust the retransmitter. So that's kind of like another big idea, is that because like cryptography is kind of like woven into it, you actually don't need to trust, like you can build community retransmitters and these nodes and kind of not have to worry that, you know, they're actually like modifying the content as it flows through them. So that's the authenticated part in it.
If I try to recap this for my understanding, so you have a very weird distribution of personal data servers. There are some with millions of users, probably the Blue Sky ones, and then there's like the people who host it in their basement.
Yeah.
And to not have every app know every PDS and like go there every time and pull them all the time, you have those relay services, which is, I imagine, like super beefy servers somewhere that for somehow know all PDSs and subscribe to all of them. And then it's just like a huge Apache Kafka, and they just pipe the events into the web.
I don't think it needs to be like super beefy. I'm not sure. Like in terms of costs, I think it's something around like $30 a month to like run it at the current volume. But yeah, it needs, you know, and yeah, they need to know the PDS on the network, which is a bit wonky because like, well, how do you know? There's a bunch of ways. Like one is just like, I think you can enumerate, like there is an endpoint on existing relays to like enumerate the ones that they know, I think. So that's kind of how you can bootstrap. A PDS can also request to be crawled. So you can decide, like if you put a new PDS online, you can like add some known relays to kind of ping them. And then you can also discover it through links, right? So like if it sees a link to, if it hasn't seen, like that resolves to PDS it hasn't seen before, it can decide to crawl it. So it's kind of up to the relay how to do it, but it's yeah, and like if it wants to just like provide an archive or to only retransmit and like have no archive. Because like keeping an archive is kind of expensive.
So if I want to build on ATProto, I have this like shared data layer, and I have like apps that are already quite successful that populate that data layer with users, and those users use those apps and therefore populate it with their own records. Yeah. And if I want to build on that, I would probably get one of those relays and just like start downloading data from there and like putting it into my own database. Is that how it works? And then my app logic on that.
Yeah, so I think this the exact way you do it depends on just kind of what data your app is going to care about, right? Because if it only cares about its own data, like if you you came up with new record types and you want to just, that's the stuff that your app displays, then you don't need to backfill it because it doesn't exist. Mm-hmm. So, if you just connect, you just start listening to like a relay and you filter it down to the stuff that like your app cares about, then once records start getting created, you will have all of them. So you don't actually need to like get anything that exists before, right? And that's kind of the easy path. And then you just have a connection to this thing and you keep track of like which like where your users are. If like you want to do something with existing data, then you have to backfill it. So you have to, well, there's really kind of two ways to go about it. Like the way I'm telling about is if you want data to be in your own database, then of course you have to somehow get it there, right? And then the question is like, okay, is it from a big app or like a small app? Because if it's something like Tangled, you can probably backfill, all records from all Tangled users in like a reasonable time, because there's just like not that much, right? Like maybe, I don't know, maybe like 50,000 records. Like I don't know how many, but it's not that much. Or like, okay, maybe a lot of records because people do Scrabble, it's like probably millions now. But essentially you just need to find like all the I think maybe Relay has an API for this, but there's like a way to find out which users or like which identities have collection of a certain type. So you can kind of figure out who are the users of a particular app and then just get their stuff. And so there are tools that do this. There's like something called Tap, which is their tool for backfill. You tell it which collections to kind of look for, and it will try to synchronize it all, and then kind of listen to the new events. But there's also like a different approach, which is, especially like if you want to, like Blue Sky, you probably don't want to download like terabytes of all Blue Sky posts that ever existed. But maybe you want to build some app on top of Blue Sky. Of course, you can use Blue Sky API. That's kind of the traditional way, but then I think it's a bit like not ATProto spirited, right? Like, well, you rely on somebody else's thing that's like app specific. But there's a tool called Constellation. It's community run. It's like a server run by community that indexes like all the records and provides an API for backlinks. So it lets you say, given this post, give me all the records that link to it, which means like that you can get like all the likes of a post, you can get all followers of a person, you can get like all quotes. It's kind of like just go in through the primary foreign key kind of query. You just like, what are all the things that link to this piece of JSON? And so this actually lets you like build a workable app without the backend even, because you can kind of just hit like you can hit the user's hosting if you need something user specific, and then you can hit Constellation if you need to kind of go one step, removed and see like all the things that this links to. So this is less efficient, but you don't need to backend at all then.
Yeah. So the more I hear about this, at first I thought like this app protocol is really complicated, but now I understand why it needs to be complicated, because it collapses the stack. So my app needs less and less. It doesn't need a data layer necessarily, because every user has their own data layer, and I can use the existing relays and everything to aggregate that. Then it doesn't need like a authentication layer, because the user is it called an Atmosphere account?
So it's kind of funny because it uses OAuth, right? So you log in through OAuth, but the OAuth provider is actually your PDS. So in a sense, it's almost like logging into Google account, except you are the Google, like you're hosting, and then you can, So this is why, like, if you change the Eurosky, when you click like login through like Atmosphere in like other apps, it's going to show the Eurosky's login page now, because that is now your hosting.
The domain is Eurosky, and that's where I log in.
Yeah.
Super interesting.
Yeah, so it's kind of lifting identity and the data. Like I think of it as that's the data layer, like people-centric data layer for the web.
That sort of also brings its own complexity though, right? For example, if you have like, let's just take Instagram, an Instagram competitor, and you want to build that app, and it's slow, and you want to debug or like improve performance. But the problem could be outside of your product. It could be the user's PDS being really slow or like laggy. It could be the relay struggling to aggregate the data. How do people cope with that?
Yeah, I think like with hosting itself, it's kind of pretty resilient. Like the idea is pretty resilient to that, because I think if you want a good app, you just shouldn't really go to hosting much, because you aggregate things as they come in. So the hosting just emits events, but like you shouldn't blast the hosting with like 1,000 requests. You just serve everything from your database or from the stuff that you've cached. So hosting being a bit like wonky is actually fine, as long as it actually emits the events that it should generate. So that isn't really like a major problem. I think it's just a server that serves some JSON. It's so it shouldn't really get laggy. Of course, like yes, for users who are, for example, on Blue Sky PJSs, and then Blue Sky is having like scaling issues, then in that case that does reflect in the app, right? Like some events like are struggling to come through, like the relay struggles to come through. I think in terms of like this is something you just kind of live with. It's it's like your app is more webby, so there's more there's more things that could go wrong. The relay itself again, if you rely on like the Blue Sky, the one run by Blue Sky, it's mostly working fine. I think there's been sometimes incidents, but it's mostly working fine. But if you don't trust it, you can definitely run your own. And then like if that is how you like completely kind of like isolate yourself from problems with like upstream, I think, yeah, like, there's like that there were also cases where like other apps that ran their own relays or like used the community relay were up when like the Blue Sky app was not working because there was like some relay problem. So I think like with time, as I think like now is like the early adopter stage where you run it because you believe that there's just a better way to kind of do web, like web products. But like I think of it as like open source in the 90s. Like if like people would tell you you're crazy, or that like Microsoft is like says it's cancer, and then like 10 years later like Microsoft is actually like running on open source. So I think like now is that stage where people tell you you're crazy. And so this is like it is like it's like early adopter pains. But because it's a standard, it's kind of like I think everything that like benefits like some apps can like benefit others because they kind of speak the same language. So there's like shared infrastructure, like Constellation, shared like libraries, tools, like different kind of things you can do with it. So I think like as that infrastructure grows and is more reusable, there will just be more like the network will be more resilient in general, because there will be just like more options with relays and more things it would be like easier to backfill. There would be like archives for just like rehydrating everything if you like lost some data or whatever. So I think we'll see more of that.
Yeah, I actually just thought of a really interesting problem concerning sustainability while you talked about Blue Sky being both the app layer and the PDS layer in their case. Because for Blue Sky, like I would clearly see a path to monetization. They have the app layer, and it would be quite easy for them to monetize that. Let's say put display ads on there or have like premium accounts. But like there are PDSs who don't have an app layer, and they have the cost. I'd say they bear most of the cost because they have the egress and the hosting cost, right? But how is there like a way for apps to give back to the PDSs, or like to sort of shift the weight of the cost structure?
Yeah, I'm not sure. Like, I think running an app is like many times more expensive than running hosting. I'm not 100% sure, but like first, like the scale of the app is open to, like the users are, the app is what kind of serves the users, right? So if you have like 1 million daily users, then that's the load that goes into the app, and then the hosting serves the apps. So that's actually like kind of more distributed already, because like especially if there are like different hosts, then if you self-host, you really only serve your own data. Like it doesn't, it's not really like, it doesn't put much like compared to something like Mastodon, where like if your post goes viral, like all the instances are gonna hammer your instance to, whereas like here it's actually like it doesn't really matter that much because the app shields you. But the other thing is like I think hosting has I think part of it is just like people don't really, it's such a novel concept that you have a hosting as a user, right? Like that's usually like you have a hosting if you have a website or like a company, but just as part of your internet experience, even though like you maybe like log in with a Google account, that's kind of the relationship you have to Google maybe. But the idea is that we can kind of lift this up and make it transferable. I think it's kind of new, right? That like there's like a Dropbox with all your social data. Like that's kind of new. So I think it's not even like recognized exactly like by the mainstream user at this moment. Like maybe in 5 years or like maybe in 10 years it would be. But you can also like offer, there could be like services that the hosting offers, right? So like I would actually like pay for just like safe backups, right? Like I would really want my hosting to just periodically back up all my data without me thinking about it. Like that could be like one thing. Some people want like more storage, maybe for like videos and stuff like that. That could also be a thing. But in general, I think it's actually the app that is much more like because things like CD, like the transcode in video, like all of that's like serving a lot of video, like all of that stuff is, I think, way more expensive than kind of serving JSON. So that is where I think like a lot of the costs actually go.
So you're saying sort of in order to run a stable app, you want to shield the PDSs from your app layer anyways, and shielding the PDSs will take most of the load off the PDSs onto your app layer. So it's sort of a like self-restraining system.
Yeah. Because you don't want it to, you want it to be reliable, and so you don't want to be like, if a page is misbehaving, like you don't want it to reflect on the app. And also, like, you just kind of have to like past a certain level of product complexity. You just have to have a database, or like you can hit community caches, but then they're shielding you, right? So if you hit Constellation, that also shields hosting, because Constellation has a cache of like everything that it has indexed.
Interesting. So what would you say is currently still missing from the AT protocol? Is there something that's not here yet?
Yeah, I mean, there's a lot of rough edges just in terms of like developer experience, or kind of what is the right way to do something. Like it's still kind of being debated. Like some things are like people are experimenting with. But I think the big thing that like the team is currently working on is permissioned data, because currently ATProto is fully focused on public data, which I think was the right focus in terms of like actually proving out that like if you start with private, that's a smaller scale, you don't know that you're going to scale up to public. Whereas if you scale up to public, you have to figure out how to do aggregation, how to do like all these things efficiently, and then you can kind of scale down to permissioned. But they're working on extending the protocol, or like having like a sibling protocol for stuff that is not meant for public retransmission, such as groups, like not like messaging, because you just want like to end for that, and that's like an entirely separate thing. You could use like a product identity still, but it's like a separate thing. Whereas like things that are kind of gated by like a membership, they're not like completely private, because like any app that has been granted access, like of course we'll see them because it needs to display them. But they're basically working on this permissioned data extension to the protocol, because right now if you want something like private or like group private, you can sort of do it, but of course with your own database. So you're kind of, which is also okay. Like ATProto is pragmatic in the sense that you can adopt just the parts that make sense to you. So you can just use the identity layer and nothing else, right? And keep everything in your database. But like ideally you would kind of move towards like ATProto refine it a bit more, but then you run into the wall where all the like group level stuff or like user preferences and stuff like this, like you kind of have to store them. There's like a hacky thing that I think you can store like it in Blue Sky preferences, but anyway, there's like no good API for private or protected stuff, and so that's what they're working on. I think that's like a big gap that there is like no way to do that now that's protocol native.
So this might be a sacrilege in a podcast with a core member, but I'm a huge fan of Svelte, and there's like in the ad world, like quite a few apps seem to be built with Svelte, and there's like someone or like a group of people trying to build a Discord clone based on ATProto. I think it's called Roomy Chat, and they seem to be stuck on having like private servers because they don't have permission data yet. But like having permission data would unlock that for them, because they could have some data being gated behind access controls, authorization.
Yeah, probably. I think so. I think like things like chats are kind of, it's just like a different modality because they're kind of ephemeral in a sense. I guess maybe for Discord, like you do want to keep it, but I don't know that you want to necessarily like every chat message be a record. Like I don't know if that makes sense. But there's definitely, I think like having permission data would like help. But yeah, like Svelte is really popular in the product community. I don't know why for sure. I think it's just maybe like fits the ethos. It's kind of like webby. Also, it has these connotations of like, it's the kind of the lighter thing or like the newer thing, and like React is like Java to these people, which is like, okay, I'll take it, whatever, or whatever, whatever works. I think
it might just be a function of Svelte adopters being early adopters,
maybe,
and then this guy also being quite early, or like ATProto.
Yeah, but I think a lot of it is aesthetic. It's just like it feels webby, and like ATProto is also very webby. So I think there's like a match there.
Okay, I think we covered so much ground in this episode. Is there anything that's like left to say? Anything that we haven't covered yet?
I would just say, I think like, I don't know, I would encourage more people to like try Blue Sky for real, like for, posting like the stuff you would normally post on Twitter. It's one thing I would encourage is to actually, like, the default feed is, I think, called Discover, is I think not very good. There is a very good custom feed called For You, literally like For You in Twitter. That if you go to the feeds tab in Blue Sky app and search for You, you will find it. I highly recommend it. It learns from your likes and like what the people who have liked the same things as you liked have also liked. And it's actually like, I just feel like it's kind of like as good as like Twitter algorithm like used to be. So I'm just like, I always use that feed. But the other funny thing is that this feed runs literally from somebody's gaming computer at home. So there's some guy who's like, again, like, because what is a feed? It's just a HTTP service that returns an array of AT URIs for posts, right? Like and because like posts, everything in the network is identified by AT URI, it doesn't matter where it's hosted. You can build these like services that understand, they're talking about the same thing. So like this For You feed, it just returns an array of AT URI and like through them. And then the Blue Sky app server, like it talks to this feed, gets the URIs, and then hydrates them from the database into actual posts. So it's very cool that like you can have like userland feeds on Blue Sky, and this is, I think, the best one. So definitely, like especially if you're like getting people to move, like trying it out, just tell them all to install the For You feed. It's just better.
I'm also on For You, and it's super, super funny because like sometimes the person who hosts it, like the feed goes down for an hour and then it goes back up, and he posts like, sorry, I had to upgrade my PC. I put more RAM into my PC or something. It's very cool.
Yeah.
Okay, I think that's it for today then. Thank you so much for coming on and talking about ATProto. I mean, you obviously couldn't say it yourself, but probably the best way to learn about ATProto is your blog, I would say. You have like a whole series of blog posts on ATProto and how it works, using different ways to break it down. I think the file system one is great. And then go on Blue Sky and just start following a bunch of people. My personal recommendation would be, they have like what is called starter packs. And it allows you with just like one click to follow all the people in your group of interest. So for example, I assume you would be in the React starter pack.
Yeah, probably, if there is one. The JavaScript, yeah.
I'm in the Svelte starter pack, which was really cool because it got me bootstrapped with like a whole bunch of likes, which I was really happy about. Okay, and actually this show is also on Blue Sky, UAT Inside. Or if it isn't, I will make sure that it will be on Blue Sky after this post. You can always check us on the regular HTTP web. Our domain is uit-inside.linecorp.com. And then make sure to follow Dan if you don't already. And thank you so much for listening. If you want to listen to other episodes, most of them are in Japanese, but there's, I think, 3 or 4 English episodes out there. So just look for them, or maybe study Japanese, or use like a tool to translate it. Dan, thank you so much for coming on.
Thank you.
Bye-bye.